Okay. So we're on question 38, right? Yeah, this one. Okay, so let me just explain, then we'll move to the next question. All right, so session affinity is a capability or a feature in load balancer, right? Now, as I said, the question is giving clues, right? So the sticky sessions should be configured on the endpoint. And the endpoint is what? Will be the load balancer, okay? And then we know that it is also a web application. So here we are looking at an application firewall. Sorry, I said application, an application load balancer. Okay. So here, the only application load balancer is this one. So you create a public application load balancer and then you specify the application target. Okay. Network load balancer works at layer 4 and they are not for applications. All right. So this will be it. There is a use case for gateway load balancer, but I'm sure when the question comes, I'll recall. All right. So 39. A company hosts an application on AWS that gives users the ability to download photos.
Are you there?
Yeah.
Hello? I think we are supposed to choose two answers.
Yes. So yes, we are supposed to choose two. Okay. So he said a WAF must be so yes. So we just create a web is here. So we also looked at what? Please, am I still audible? It looks like it looks like we need to start, what's it called? The the prayers before this is the day.
I feel like MTN they mess up. But you they use MTN.
I said Vodafone or Vodafone. You did hear me? I mean, you did hear me? Yeah, this one said it be Vodafone. No, it be Vodafone then they do me so.
Richard they use MTN, but my own they also they go on and off.
Huh. Okay, the recording is still. Yeah, so Sita, thanks for prompting. Please, am I audible?
Yes, you are.
All right. Yes, thanks for prompting me. All right, so we configure the application load balancer and then specify the target group. And then with WAF, because he said WAF must be applied to the endpoint for additional security. So in WAF, we learned that we are able to create what? web access controllers in WAF, and then it can be associated with the endpoint. And here the endpoint is what? Is the application load balancer. We looked at the BP1, the BP2 for some of the architectures when we did the lesson on security, right? Okay. So 39. A company hosts an application on AWS that gives users the ability to download photos. The company stores all photos in Amazon S3 buckets that is located in the US East 1 region. The company wants to provide the photo download application to global customers with low latency. Which solution will meet these requirements? It says find the public IP addresses that S3 uses, right? So here we are looking at 7 photos there. They are static content, right? Configure an Amazon Route 53 latency-based routing policy that routes to all the public addresses. B says configure Amazon CloudFront distribution in front of the S3 bucket. Use the distribution endpoint to access the photos that are in the S3 bucket. C says configure Route 53 geo-proximity routing to route the traffic to the S3 bucket that is closest to each customer's location. And then D says create a new S3 bucket in US West 1, configure blah, 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 to copy the photos to the new S3 bucket. Okay, so we have 3 Bs. Yes, obviously, CloudFront distribution will work in this case, all right? 40 says, a solutions architect is designing a disaster recovery strategy to provide Amazon EC2 capacity in a failover AWS region. This one, it might trick us small, but I believe in all of us. In a failover AWS region, business requirement states that the disaster recovery strategy must meet capacity in the failover region. Which solution will meet these capacity requirements? So A says purchase on-demand instances in the failover region. B says purchase an EC2 savings plan in the failover region. C says purchase regional reserved instances in the failover region. And D, purchase a capacity reservation in the failover region. Okay, so I have B. So let's look at this. So B says purchase EC2 savings plan in a failover region. Now, EC2 savings plans was doing practitioner, right? I remember that EC2 savings plans is when you commit to a certain usage, right? A certain usage duration, sorry, for a period of either 1 year or 3 years. So you commit to a duration, let's say 24 hours a day, 7 hours a day, 3 hours a day, 4 hours a day, right? But here it says that the strategy must meet capacity. It must meet capacity in the failover region. All right. Regional reserved instances in the failover region. For this one, I don't know. But basically, if there is anything like that, since they said AWS will not bring anything that does not exist, it means that this is specific to a region. All right. So that wouldn't be it. On demand will also not be it. All right. So it leaves us with what? Capacity reservation. So let's just, for learning purposes, let's just look at AWS capacity. What's the is it okay? Capacity reservation.
Sorry to interrupt you guys.
That's fine.
So someone just passed the AWS and the person is saying the dumps from the group really help. The YouTube dumps really help. So yeah, I'm letting you guys know.
All right. All right. So okay, this is your there.
So yeah, well, I just saw the person's message. That the
Yes.
person that she just saw that she has gotten the badge, but she hasn't really checked.
My issue is I don't know if I should keep learning or stop and go and do dumps. That's what I mean.
If I do both to sake of me, the dumps make us see some services are not really they familiar with. So if I go back then go read on them, then someone to come back to the dumps again. So as for any talk, the dumps they need. But there are YouTube video there you can go through.
Lambda at edge catch location and things. Hey.
I say, oh.
Then they put lambda for where lambda not for this. Hey.
Okay. So capacity reservation allows you to reserve compute capacity in EC2 on a long-term basis. So this can help you save money on your EC2 costs, and it can also ensure that you have capacity you need to run your applications. All right. So these are benefits. So you are able to ensure capacity and you're able to scale quickly. All right. So that makes capacity reservation. I want to see the documentation on demand with capacity. Let me see capacity reservations. Let's see here.
Why you don't go search capacity reservation for failover?
Okay, let me do it that way. Yeah, but basically, since the question is saying that it should what? Ensure capacity in the failover. So capacity reservation makes the correct. All right. I want us to, oh, so I have to add AWS. Wait, when I'm with that. Yes, so manage your version. Specify period of time. Let's ensure that's during the yeah, for machine learning. They updated it this year. Nothing. Dedicated, reserved. Okay, guys, let's just move on. But then the only option that ensures like the capacity right? In the failover, the same capacity in the same failover region is the capacity reservation. A company has an application that runs on Amazon EC2 instances and uses an Amazon Aurora database. The EC2 instances connect to the Aurora database by using usernames and passwords that the company stores locally in a file. The company changes the usernames and password every month. The company wants to minimize the operational overhead of credential management. Which solution will meet these requirements? So AC store the credentials as a secret within AWS Secret Manager. Assign IAM permissions to the secret. Reconfigure the application to call the secret and enable rotation on the secret and configure rotation to occur on a monthly basis. B says use Systems Manager parameter store to create a new parameter for the credentials. Use IAM policies to restrict access to the parameter. Reconfigure the application to access the parameter. C, create Amazon S3 bucket to store objects used. I will not read this one. D, create encrypted. This one I will not read. So the answer is between A and B. Okay, so yes, A is the correct answer here, all right? Because it says the company changes the usernames and password every month. So here we are looking at a service that's able to store credentials and also has rotation capability, right? And here that is what Secret Manager does. You know, if it wasn't for the rotation, then Systems Manager parameters to store would be the right option. Okay. 42. A company has a data ingestion workflow that includes the following components: an Amazon simple notification service topic that receives notification about new data deliveries, an AWS Lambda function that processes and stores the data. The injection workflow occasionally fails because of network connectivity issues. When failure occurs, the corresponding data is not ingested unless the company manually reruns the job. What should a solutions architect do to ensure all notifications are eventually processed? A says, configure the Lambda function for development across multiple AZs. B says, modify the Lambda function's configuration to increase CPU and memory allocations for the function. C says, configure SNS topics retry strategy to increase both the number of retries and wait time between retries. D says, configure SQS queue as the on failure destination. Modify the Lambda function to process messages in the queue. Right, so here, this is also a no-brainer because, you know, for SNS, it publishes the notification once, right? So for retry to happen, then it means the message should be in a queue. And then, you know, SQS queue has what we call dead letter queue, all right? So anytime there is network issues, then it can send it to the SQS queue for further processing or for retry purposes, all right? 43. A company recently migrated its web application to the AWS cloud. The company uses an Amazon EC2 instance to run multiple processes to host the application. The process includes an Apache web server that serves static content. The Apache web server makes requests to a PHP application that uses local Redis server for user sessions. The company wants to redesign the architecture to be highly available and to use AWS managed solutions Okay, and to use AWS managed solutions. Which solution will meet these requirements? So A says use AWS Elastic Beanstalk to host the static content and the PHP application. Configure the Elastic Beanstalk to deploy its EC2 instance into a public subnet. Assign a public IP address. B says use Lambda to host the static content and the PHP application. Use an Amazon API gateway REST API to proxy request to the Lambda function. Set the API gateway cross-origin resource sharing, right? That's cross-origin resource sharing configuration to respond to the domain name, and configure Elastic Cache for Redis to handle session information. C says configure the backend code on the EC2 instance, create an Amazon Elastic Cache for Redis cluster that has multi-AZ enabled, configure the Elastic Cache for Redis cluster in cluster mode, copy the front-end resources to Amazon S3, configure the back-end code to reference the EC2 instance. This is configure an Amazon CloudFront distribution with an S3 endpoint to an S3 bucket that is configured to host the static content. Configure an application load balancer that targets an Amazon Elastic Container Service that runs AWS Fargate tasks for the PHP application. Configure the PHP application to use an Amazon Elastic Cache for Redis cluster that runs in multiple availability zones. Answers. I don't know. Okay, so let's look at the question. So here it says it's what? A web application. It's a web application that has been migrated to the cloud, right? So it uses EC2 instances that runs multiple processes. So it includes an Apache web server and then also a PHP application. So it looks like, yeah, so it looks like an application that has a lot of dependencies. We know Beanstalk is for application deployment. So it's just to aid in, the expedition of your deployment, okay? Now, using Lambda to host the static content, blah, blah, blah. Anyway, now keeping the backend code on an EC2 instance, that just looks like a lot of overhead. Even though this answer seems short, that seems like an overhead. So the best thing is what? To configure a CloudFront distribution with an Amazon S3 as the endpoint, all right? To host the static content. And then now all the dependencies will be stored in a container, okay, that will run the tasks for the PHP application, right? And then we'll put an application load balancer in front of the ECS, and then we'll configure the PHP application to use Elastic Cache, right, for Redis cluster that runs in multiple application availability zones. So here, everything in here, all the components has been what satisfied in here. So even though this looks like plenty, but this is the viable solution. So that's why I said that some of the answers, they might look long, and then you might think that, oh, this one is operational overhead, blah, blah, blah. But they might be the correct answer. You have to understand the use case and the concept. Okay. So 44, a solutions architect is using an AWS CloudFormation template to deploy a 3-tier web application. The web application consists of a web tier and an application tier that stores and receives user data in Amazon DynamoDB table. All right. The web and application tiers are hosted on Amazon EC2 instance, and the database tier is not publicly accessible. The application EC2 instance needs to access DynamoDB tables without exposing API credentials in the template. What should the solutions architect do to meet these requirements? A says create an IAM role to read the DynamoDB tables. Associate the role with the application instance by referencing an instance profile. B says, create an IAM role that has the required permissions to read and write from the DynamoDB tables, add the role to the EC2 instance profile, and associate the instance profile with the application instances. C, use the parameter section in AWS CloudFormation template to have the user input access and secret keys from an already created IAM user that has the required permissions to read and write from the DynamoDB tables. And D says, create an IAM user in the CloudFormation template that has the required permissions to read and write from the DynamoDB tables. Use get ATT, so that's get attribute function, to retrieve the access and secret keys and pass them to the application instances through the user data. Answers? Okay, let's break it down. So we have a 3-tier application, right? The application tier, the web tier, and the application tier. So the web tier definitely is in the public subnet. The application tier, okay. Godman, you still look at the, all right. The web application tiers are also hosted on an EC2 instance. The web and application tiers are all hosted on EC2 instance. Now, the database definitely will be in a private subnet, all right? So it's not publicly accessible. Now, the application instances need to access the DynamoDB tables, which means that they need to write and then read from the DynamoDB tables. Like most of the web application tiers, that's how it is, right? They should be able to read and write from the DynamoDB table. Okay, so if that is the case, we are looking at where the application instances are able to what, read and write into the database. Now, when we look at here, C has the read and write thing, right? And then B also has read and write. Okay, this one also only has read capability, even though it might look viable, right? Here, create an IAM rule to read. So the only thing that disqualifies this is what? The fact that it only has read here. All right. So as it stands, an IAM rule that has the required permission to read and write from the DynamoDB tables, and then add a rule, because what is the requirement here? Says the EC2 instance needs to access the DynamoDB tables without exposing any API credentials. All right. So here it just has a rule. So anytime it needs to read and write, it will just assume the role. That's the operation, and then go back to its usual role. All right. So this one seems viable, but let's look at the other ones too. Using a parameter section in CloudFormation template, it means that you are going to store these credentials. These credentials will be in the CloudFormation template. So one way or the other, you are exposing it. All right. Here also says you create an IAM user in the CloudFormation template. As far as I recall, I don't think you are able to create an IAM user with, even if you are able to create an IAM user, right, that has the permission. Now you are now going to use a get attribute function to retrieve and access the secret keys before you even pass them. So here you are still exposing the API credentials. All right, so it makes B the most viable answer, right? So you just need a role. You don't even have to give any credentials. It's just the rules that will be used to do the read and write. Right. So 45. A company has 5 organizational units. So here, AWS organizations, right? as part of its organization in AWS organizations. Each OU correlates to the 5 businesses that the company owns. The company's research and development business is separating from the company and will need its own organization, right? So the R&D business is separating and it will need its own organization. A solutions architect creates a separate new management account for this purpose. Now, what should the solutions architect do next in the new management account? Right? So A says have the R&D AWS account to be part of both organizations during transition. B says invite the R&D AWS account to be part of the new organization after the R&D AWS account has left the prior organization. C, create a new R&D AWS account in the new organization and migrate resources from the prior R&D AWS account in the new R&D AWS account. D, have the R&D AWS account join the new organization. Make the new management account a member of the prior organization. Okay. Godman says D is popping. Unfortunately, D is not popping. All right. So let's look at this. So it says the R&D is separating from the company. So the whole R&D business, the research and development business, is separating from the company, and it means that it will need its own organization. So let's look at D first. So R&D account join the new organization, and then now make the new management, because a new management account has been created. And then now again, make the new management account a member of the previous organization. Okay, so it means that it will still, the R&D account will still be a member of the previous organization, which is not what we want. We want like a total separation. All right. So A and D will be out, right? Having the R&D AWS account to be part of both organization also will be off. All right. Now invite. So the answer is between C and D. Okay. Here, let's look at C. Create a new R&D account in the new organization. So that's the new management account, right? And then migrate resources from the prior R&D AWS account to the new R&D AWS account. Now, there is no need to actually migrate anything. Okay. There's no need to migrate anything, because when you move, what it does is it only affects the billing and then the hierarchy. Okay, the billing and then the hierarchy. So it means that you will not be able to enjoy consolidated billing and then all those things. Okay, you are only not under the organization. So here, what you do is that after you have created the new management account or the new organization account, the AWS account, whatever organization that they were in, organization accounts that they were under, they have to leave first. God money, they laugh. They have to leave first. So after they have left, then you invite that account to be part of the new organization. All right. So let's just do something here. How do you transfer an AWS member account from another organization? So you see, so moving an account between organizations requires you to remove the account from an organization first, and then making the account stand alone, and then you accepting an invite to join another organization, right? So during and then after the account transition, you would want to ensure any workload services continue to operate. Okay, so this is it. Just remove, send an invite, accept the invite, click accept invitation to complete the process of joining the organization, right? It's as simple as that. All right. So it makes B the correct answer. 46. A company is migrating 5 on-premises applications to VPCs in the AWS cloud. All right. Each application is currently deployed in isolated virtual networks on-prem. Okay. So that's the reason why. So they all have different networks. That's why they are sending it to VPCs and should be deployed similarly in the cloud. So the same architecture on-prem should be in the cloud. The applications need to reach a shared services VPC, right? Shared services VPC. All the applications must be able to communicate with each other. If the migration is successful, the company will repeat the migration process for more than 100 applications. Which AWS solution will meet these requirements with the least administrative overhead? So here, this deploy a software VPN channels.
Like, scroll up slow. Please scroll up.
Is it okay?
Yeah, it be okay.
Right.
I go house that. Yeah,
So A says deploy software VPN channels between the application PCs and the shared services VPC. Add routes between the application VPCs in their subnets to the shared service. B. Deploy VPC peering connections between the application PCs. No, this one should be VPCs. Why PC? The application VPCs and the shared services VPC. Add routes between the application VPCs and in their subnet to the shared VPC, to the shared services VPC. Through the peering connection. C says deploy an AWS Direct Connect connection between the application VPCs and the shared service VPCs. add routes from the application VPCs in their subnets to the shared services VPC and the application VPCs. Add routes from the shared add routes from the shared services. Okay, from the application. Okay. So add routes from the shared service VPC subnet to the application VPCs. And then this is deploy a transit gateway with associations between the transit gateway and the application VPCs, right? And the shared service VPC. Add routes between add routes between the application VPCs in their subnets and the application VPCs to the shared service VPC through the transit gateway. Plenty VPC. Okay. So let's see the correct answer. Godman, and I say this one too. What's it called? The pap, did the pap. So no CVC. Oh no, wait. VPC pairing day. Okay. So let's look at this. So we are looking at the applications need to reach a shared services VPC. All the applications must be able to communicate with each other. So it means that the VPCs are in, let me bring the annotator, right? So we have VPC1, VPC2, VPC3, VPC4, and VPC5. Okay. Now, it says that all the applications should be able to communicate with each other. That is just what I want. Forget the shared, all those things, blah, blah, blah. They should communicate with each other. Now, if you are using VPC peering, all right, direct connect there is out of the whole show because direct connect takes months, right, to establish. So we're not there. It's out of the equation. Now, if we want these applications to communicate with each other, it means that we have to do this, do this. That's VPC peering. Do this, do this. Okay. This has to communicate with this. This has to communicate with this. This has to communicate with this. And this has to also communicate with this. Finish. So this one is able to communicate. This one is able to communicate. This one is able to communicate. This one is able to communicate here. And then another connection has to come from here to here. I hope you understand. Now, okay, so that is it. All right. So it means we have to set up plenty peering connections. Meanwhile, if we had, if we just provision a transit gateway here, this one connects 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 here. We are done, right? All the applications will be able to what? Communicate with each other, right? With the least administrative overhead. So here, all we need to do is set up a transit gateway, do the connections, right? By doing the routes and then all that. And that is it. The work is done. Communications will be established peacefully without us. Because if you do the peering connection, you have to configure the route tables for this and this. You do this and this. You configure the route tables. You do this and this one. You configure the route tables. You do this and this. You configure the route tables. You do this and this. You configure the route tables. Same here. Before you do the route tables, like a lot of work, right? So let's take or put that in mind. All right. So it makes key. The answer 47. A company has multiple VPCs across AWS regions to support and run workloads that are isolated from workloads in other regions. Because of a recent application launch requirement, the company's VPCs must communicate with all other VPCs across all regions. Which solution will meet these requirements with the least amount of administrative effort? A says use VPC peering to manage VPC communications in a single region. Use VPC peering across regions to manage VPC communications. B, use direct connect gateways across all regions to connect VPCs across regions and manage VPC communications. C, use transit gateway to manage VPC communication in a single region and transit gateway peering across AWS regions to manage VPCs communication. D, use private link across all regions to connect VPCs across regions and manage VPC communications. Answers. Godman and Sitaj. It looks like I can't move. Move better move my answers and move answers, but then we'll solve it.
I please start explaining why. This one day.
Okay. So it's the same concept, right? So they have multiple VPCs across AWS regions, right? And then now they need a way for the VPCs to communicate with each other. All right. So here, the same thing. One VPC here, right? So let's say region 1, R1. Let's say we have 3 VPCs. Okay. And across AWS region. So let's say region 2. No, let me put region 2. Region 2, right, has also 3. Now, well, you can have, let's say you even have VPC peering. You have VPC peering between these. If you have VPC peering, how do they communicate across regions? It means that you have to set up VPC peering across regions. The same thing, right? Plenty VPC connections. So what you can do, transit gateway, use what we call what hub and spoke, right? So the transit gateway will be the hub. So what we do is that you set up a transit gateway, connect, set up another one, connect, okay, and then you can connect these 2 transit gateways. right? So that's why it's saying that use transit gateway to manage VPC communication in a single region, and transit gateway peering across regions to manage VPC communications. Right? Private link is for VPN connections. And so peering, and here direct connects isn't it, right? Because you want a way to just for your VPC communications, VPCs to communicate with each other, right? So it is through transit gateway you are able to connect like two different VPCs or VPC connections across regions. Mm. And I'm open to Google.
It'll be okay.
No, I'm okay. So if you need to connect multiple VPCs, the first option should be transit gateway.
Yes, across regions, right? But if they say, oh, it has two VPCs and then the VPCs need to communicate with each other, there's no need to use a transit.
Then
Just do VPC
peering.
Yes, VPC peering between the two.
Okay.
And you are okay.
Okay.
And there is another one. You use what we call VPC sharing, right? That is where you have two accounts have VPCs, okay? But then maybe I have a database, right, in my VPC that you would want to use. I want to share with you, okay? What I need to do is that I need to use VPC sharing to share my VPC and then the subnets that has the resource in it with you. All right, so that's what that one. The answer will have VPC sharing. Use VPC sharing to share one or more subnets with and then the resources with the other accounts. Okay. So that's the two.
So Isaac, that would be between two different, like maybe organizations.
Accounts, two different accounts, right?
It doesn't have to be okay.
Yes, two different accounts, probably under the same organization or which people are chatting in the Awesome 30 group. They will not come to the meeting and they are there chatting. All right. A company's infrastructure consists of Amazon EC2 instance and Amazon RDS DB instance in a single AWS region. The company wants to back up its data in a separate region. Which solution will meet these requirements with the least operational overhead? So A says use AWS backup to copy EC2 backups and RDS backups to the separate region. B says use a data lifecycle manager to copy the backups. C says create Amazon machine images of the EC2 instance, copy the AMIs to the separate region, and then create a read replica for the RDS DB instance in the separate region. D says create EBS snapshots, copy the EBS snapshots to the separate region, create RDS snapshots, export the RDS snapshot to Amazon S3, and configure S3 cross-region replication to the separate region. Should I explain this one too? Ah, which one be the X? Hey, answer by you X-Men that are here. I see A, I see C. Okay, so let's look at C. Here, you want to back up, right? With the least operational overhead. So you want to back up the data to a separate region with the least overhead. Now let's see. you have to create the AMI yourself of the EC2 instance, right? Now you do the copy to the separate region, and you now come and create the read replica for the RDS-DB instance in the separate region. So I feel like this will be a lot of work. Data Lifecycle Manager, that be. And then EBS, now you create snapshot, you come and create another snapshot, you create what, export it to S3, and then all of that. Now, I would choose backup, all right? AWS backup. Now, let's see what AWS backup does. Oh, I closed my console. When the thing went off. Okay, I don't have to sign in. Okay, Godman, there's a similar question in the YouTube down there. So now we'll be in answer. Share the YouTube down things. I don't pay attention for Fabia. God, okay, the part 2. No, I've not watched the part 2. I just watched the first one. Yeah, so here the backup is build backup plans that define your requirement, including backup schedules, backup return. No, I want something. I want something that will speak. So supported service, you can see EC2 RDS. All right, so you're able to just automate backups for your EC2 instance and then your RDS. So you don't have to, worry about coming to do your backup always, right? So just this, because the company wants to back up the data in a separate region. Now, which solution will meet the requirement with the least operational? So that's the whole thing, the least operational overhead. So when it comes to reducing operational overhead, forget about cost. All right. Don't think about cost. Now, when it comes to cost, then you are looking at the trade-offs. So it means you will now want to do the work to save certain costs, because here, for example, here, if you taking the snapshot will be less expensive, right? Then just copy the snapshot to another region and then create an RDS snapshot. You put it in an S3 and then you do a cross-region application. This will be very cost effective, but that will take a lot of work. C is also the same thing. Even though it doesn't look like a lot of work, but you have to wait for the AMI to finish creating. After that, you have to set up the copy to go to another region, even assign IAM rules. When we did a lab on controlling user access with IAM, you see when we are copying the AMI, what it took, right? Some people even have to delete and then copy it again, right? Now create a read replica for your RDB instance in a separate region, okay? But backup, you can just automate it and then you are done. Even though, yes, you pay for data transfers, the backup size, I think, and then the data transfers across region as well. But then it gives you a least operational overhead, right? 49. A company stores several petabytes of data across multiple AWS regions. The company uses AWS lake formation to manage its data lake. The company's data science team wants to securely share selective data from its accounts with the company's engineering team for analytical purposes. Which solution will meet these requirements with the least operational overhead? A, copy the required data to a common account and create an IAM access rule in that account. Grant access by specifying a permission policy that includes users from the engineering team accounts as trusted entities. B, use the lake formation permissions grant command in each account where the data is stored to allow the required engineering team users to access the data. C says use AWS data exchange to privately publish the required data to the required engineering team account. And D, use lake formation tag-based access control to authorize grants cross-account permissions for the required data to the engineering team account. This one, let me explain. So it's just a little reading that I did on lake formation. Now, they want to share selective data, right, from the account. And one thing with lake formation is that you are able to tag, right, data. Okay. In fact, all these looks viable, IAM, blah, 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 right? But later, the formation, the AWS Lake Formation has a feature called tag-based access control, right? So with that, you are able to tag certain data, right? So if you want to just share, you use the tag-based access control to authorize and then grant cross-account permissions for the required data to the engineering team. Okay, so for that one, that is just it. Right, so it will just allow you to create the policies, the IAM policies that you want, right, based on the tags associated with the data or those resources. All right, and then just share it with the engineering team. So it means you will not have to share everything. It's there. Okay, so this is the last question. The company has an application that is running on Amazon EC2 instances. A solutions architect has standardized the company on a particular instance family and various instance sizes based on the current needs of the company. The company wants to maximize cost savings for the application over the next 3 years. The company needs to be able to change the instance family and size in the next 6 months based on application popularity and usage. Which solution will meet this requirement cost effectively? So compute savings plans, do instance savings plan, zonal reserved instances, standard reserved instances. Hey, hey, hey. Okay, I'm seeing D. I'm seeing B. So by Yes, so the company needs to change the instance family and sizes. Yes, correct. So Godman, what will be your answer? It was B. Yeah. Okay. So for me, honestly, as for this one, I don't know. For this one, I don't know. So let's look at, but then for zonal, right? Zonal is not part of it because zonal it enables you to reserve instances in a single availability zone or in a specific availability zone. And then for the standard reserved instances, we are not able to change, right? So since they are saying instance type, I was looking at compute savings plan and then instant savings plan, right? So let me see something. Let me look at EC2 instance savings versus compute savings plans. Okay, so this one says EC2 instance savings plans can only be applied to a specific instance family and region. Compute savings plans can be applied to any instance type, size, family, and operating system and tenancy. Okay, so compute savings plans cover usage in all regions, while EC2 instance savings plans are limited to a specific region. This one talk about regions? Okay, there's no region factor. Both EC2 instance savings plans and compute savings plans require commitment of either 1 year or 3 years. So let's choosing the right specific needs and usage patterns of customers who primarily use and are confident in their usage levels of best workloads and desire for greater flexibility may. Hey, I think the one that gives flexibility is the computer. So I think okay, so how I can let me see. Documentation. Okay, so for compute savings plans, you can change from C4 to M5 instances. Shift a workload from UU to okay, and then let's look at this. Exchange for usage M5 regardless. So here, instance plan savings give you the flexibility to change your usage between instances within a family. So you can move from C5 large running Windows to C5.2 large running Linux and automatically benefit from savings plans. And then here, you can change from the instance type to another instance type. And then here, what does the question says? Change the instance family sizes. Okay. So I think here the savings plan is correct, right? Because if you have said instance type, Godman. So let's look at this one well, right? Because here, if no wait, no the once it doesn't mention region in the question, that's it. Yeah, so EC2 is region specific, correct? So that's complete. Good. Sorry. So this one is actually the C5 flag here is an instance type, right? And then C5, so it's within the same family. But here, from C4 to M5, it means we are moving from the family, all right? You are moving from the C family to the M family. And the question also says that it needs to change the instance family and sizes. So that makes it compute. Yeah, and then it also doesn't mention region. EC2 is region specific. So it makes compute savings the correct answer. Please, I hope we are all clear. Okay, so this was our last question. If there is any question or anybody wants clarification, please you are free to ask. The sheet is available to all of us, so you can also go back and then review the answers. Anyway, so I'll end here. Okay, link to the sheets. Let me share it again. But it's in the study group though. And I shared it in all the other groups as well. Okay. Kevin, thank you. Kevin just posted a link. Okay, so if there is no other thing, let me just stop the recording.